Hello everybody, my name is Jan Seifert, I'm product manager for Digimat software, and today I want to give you a quick demonstration for Digimat Solutions Reinforced Plastics Digimat RP. RP is a GUI environment that allows to load in some FE analysis, associate a micromechanical model to that analysis, choose a solution engine, map local microstructure onto the structural mesh, launch the integrative simulation, and take a look at the results. In the scenario that I brought today, I call it the linear scenario, we assume that an FEA input already exists. In this case, we will start from ANSYS Workbench environment. We assume that an injection molding simulation has previously been run, so we rely on a set of exported files here. We go with the simplest approach to material modeling, which would be linear elastic material as provided internally in Digimat RP in a generic fashion. But we will add some extra challenge, means that it will be complex to map the microstructure information from the injection molding mesh onto the structural analysis. Let's see how the user would proceed. He would certainly start inside a workbench, so we look here at our simulation model. The mesh is well structured and quite symmetric. We apply some tensile boundary conditions on the model, and for an isotropic material model, if we look at the maximum principal stresses, we see that we have maximum stress of about 400 megapascal and a symmetric pattern of the stress distribution of the part. Now, if we want to go to RP, we write an input DAG from inside Workbench. This is done. And now we would access the Digimat multi-scale material modeling platform and choose the solution Digimat RP. In the RP GUI, it starts by loading in the input DAG that we have just exported. So here we see our model. And now we would proceed by adding the Digimat material. We have choices of different sources of material that we can load. And in this case, we just take the generic data. So here you see a full list of what we provide for a linear elastic performance. And here I like to choose a PBT glass fiber reinforced with 50% fibers for room temperature. So this is, in terms of material behavior, what is being displayed on the bottom of that window. The solution procedure is micro, so an interactive computation of material properties on the fly during the FE run. And what we need to do now is to load in the injection molding data. I load in the injection mesh. This is what is displayed here, and now the associated fields, which is the local fiber orientation. And now this data I have to transfer onto the structural analysis here. So I can click map required fields, and I get a warning that I have quite dissimilar arrangements of the mesh. A bounding box is also computed, and basically that tells me that I will need to proceed with manual mapping actions. So inside Digimat Map tool, I can take some advanced functionalities to check the situation further. So what I see here, that indeed I have dissimilar arrangement of the two models in terms of position in space, but also in terms of orientation. So I go to a transformation tool where I can superimpose both meshes. And basically what you can do here is you can pick nodes and superpose the nodes to be able to rotate and translate the meshes in space. So I picked 3 nodes in the simulation mesh. So I picked 3 nodes in the injection mesh. and I will do the same for the structural mesh. This being done, I just click on OK, and automatically the meshes will be modified, and I can switch back to my control tool, check, and I see now that both meshes are in the same position in space and have the same orientation. That means I can proceed with mapping. I will be guided through all the mapping procedures in a GUI fashion here. I have a successful mapping, and I can even control now the quality of the mapping between the two meshes. All these are advanced capabilities that you find in Digimat Map. To return now to Digimat RP, it's necessary to save the orientation, so it writes the mapped file to my computer. I simply close the map module, and here I have now the mapped fiber orientations in the coupled analysis. Everything is well defined if we look here on top, and I can click the submit button. I choose to solve my analysis in a custom folder, so I just confirm that. I get an overview over the files that are associated to the coupled analysis, and now I can click on run locally, and I run in my chosen folder with one CPU. I get to the monitoring window of my FE analysis. On the bottom, I see all the messages that come from the Digimat ANSYS interface. So I see it nicely running, and on top I see a summary of the iterations of the FE solver. Then once the job has computed and completed, I can just directly access the results by clicking yes, please open the results of the coupled analysis in the post-processing environment of my solver, in this case ANSYS, so we return here to ANSYS Workbench. Automatically my model will be generated, so I find the solution, and what I can do, I can add an additional solution that would be again my maximum principal stress. I evaluate that result, and now I can compare to what we previously had, and what I can see now is, if I zoom in, a really disbalanced stress pattern with lower stresses that I have seen before. So you see here on the left side the pattern with the larger stresses, on the right side some lower stresses, and also the overall plateau of the stresses is much lower than what we previously had with an isotropic model. All those results are definitely originated in the injection molding process that we have coupled to the analysis. And that is already the end of my short demo that I wanted to give. So if you're curious and you need more information about Digimat RP, please do not hesitate to This is already the end of the short demo that I wanted to give today. So if you're curious now and you need more information, do not hesitate to contact support@extreme.com.